Hello everyone, myself Jayan Sharma along with my team members Ruben, Anuj and Vibhor will be giving a presentation of a project that is analysis of various factors to predict crimes in the city of Chicago, which we did as a part of MSIS 5633 curriculum requirements under the guidance of Dr. Brian Hammer. Now coming on to the introduction of our presentation. Now, of the three largest metropolitan cities in United States, Chicago has the highest crime rate. Well, so for the benefit of society and the residents of Chicago, it is imperative to reduce crime rates. Now, crime rates can be reduced if we grasp a better understanding of the surge in crime rates, and therefore our project aims to direct its focus towards factors that increases the crime as well as the factors that deters the crime. Once we are able to identify the factors exerting an influence over the crime rate, we can surely understand the reasoning of crime and the occurrence of crime and thereby act to prevent the crimes before. So now let's discuss the scope of our project. Now the project aims to identify the factors that increases crimes as well as the factors that decreases the crime rate. And the ultimate aim of our project is to predict crimes in Chicago before they happen. Now, although we are trying to predict crimes in Chicago and identify the factors that influence the crime, we haven't overlooked the residents of Chicago and the police department of Chicago, which are the real beneficiaries of our project, as a result of our project will be providing residents with a safer neighborhood and also a good understanding of the occurrence of crime. Now, coming on to the objective of our project. The first objective of a project is to identify factors that catalyzes the occurrences of crime. The second objective is to identify factors that deters the occurrences of crime. And the third and ultimate objective of our project is to build a predictive model based upon these identified factors so as to prevent crimes in Chicago. Before coming on to the data access of our project, all the data that we used for this project was collected from different data sources. The primary Chicago crime data was collected from City of Chicago data portal, and the weather data of Chicago was collected from the National Climatic Data Center (NCDC). We did no data piracy to extract or get the data, and some of the data sets that we've used for a project are Chicago crime data from 2011 to 2015, Chicago weather data, Chicago census data, Chicago police station, and business data. Coming on to the data cleaning and reduction, we had 6 data sets in our analysis, and only one of our data set had missing values in it. We used the IBM SPSS statistics to impute the missing values using the mean of nearby points approach. Also, we only included the relevant variables in the final dataset that we had so as to make a dataset compact and relevant. For better analysis, we even changed some of the variable types like date and time into some categorical from some category variables to numerical variables. And also on the basis of Illinois Uniform Crime Reporting, we subdivided 33 primary types of crime into 2 categories, that is indexed and non-indexed crimes. Now discussing the data transformation, some of the data attributes that we had were not following the normality and the appropriate skewness levels, so we had to use appropriate transformations over them. For example, the weather data that we had, it was highly left skewed, and we had to use the max normal transformation to handle this problem. The unemployment rate that we had, it was right skewed, and we used exponential transformation to deal with it, and the distribution was relatively improved after we used the transformation. We also created some new variables such as crime rate per month, which I'll discuss in the next point, and some secondary attributes such as crime location distance from police station and crime location distance from business places. Coming on to the crime rate, we calculated the frequency of crimes for all 33 types of crimes in our data and aggregated it on a monthly basis, thus forming a first data set with crime rate per month matched against socioeconomic factors such as unemployment rate, hardship index, etc. Let's discuss data consolidation. I must tell you, data consolidation was one of the biggest and trickiest tasks of our project. Merging such a huge data with multiple data sets was indeed a challenging endeavor, and we had to use IBM SPSS Statistic, IBM SPSS Modeler, and MS Excel and Oracle to do this task. We used several attributes such as community area number as primary key to join primary crime data with census data. Also, a common variable VOD was used to merge business location data to the primary data that we had. And also, in order to establish the relationship among several different attributes such as unemployment rate, weather, we use the date dimension to combine secondary crime data with those datasets. Now I call upon my fellow team member Vibhor to discuss the exploratory analysis that we did for our project.
Thank you, Jen, for letting me in. Now I'll be talking about the exploratory analysis. For the exploratory analysis, we use the Tableau software, which provides with great visualization tools. Now I'll be explaining the graphs that we found out with the Tableau software. First of all, we plotted the primary types, that is the crime type, against the number of crime records. So for this purpose, we plotted a bubble chart where the primary type is color coded and the size of the bubble corresponds to the frequency. So from this graph, we found out that the primary types theft, battery, criminal damage, and narcotics were the highest crimes in the city. The next graph that we found out was the unemployment and the number of primary types. To observe the relationship between the unemployment and the number of primary crime, we plotted the total count of number of records and number of unemployment. The count of unemployment have been color coded on a scale with the darkest corresponding to the highest value. We observed from the figure that as the number of unemployment persons increases, the total count of primary type increases too. It is evident from figure 2 that in the year 2012, when the number of unemployment persons in the city were highest, the total number of primary type crime was maximum at 50,534. Next, we found out the number of arrests according to the crime type. So in the figure 3, we observe the relationship between the primary type and the percentage arrest. We observe that the primary types narcotics, battery, and theft have the highest arrest percentage at 33.54, 17.14, and 9.93% respectively. On further analysis, we observe that the primary types narcotics, battery, and theft have the highest count of arrest, which is shown in figure 4. Next, in figure 7, we see the relationship between the unemployment percentage and count of number of crimes. We plotted the unemployment percentage against the number of crimes. It was observed that as the percentage of unemployment increased from 10% to 22%, the number of crimes also increased. The crimes which increased due to increase in unemployment percentage were narcotics, battery, criminal damage, and theft. Next, we saw the relationship between the crime type and the average distance from the police station. In the data, we calculated the distance of crime location in each district from the police station in that particular district. The average distance of each primary type was plotted against the average distance from the police station. In the figure 8, we can see that battery, assault, criminal damage occur at larger distance from the police station. Next, we did the descriptive statistics of all of our data sets to find out the range, minimum, maximum, and outliers values for each of our variables. The figure that I present in the slide is one of the instance of a particular data set that we found out because the complete descriptive statistics of the dataset is too large to be presented in the slide.
Thank you, Before. I'm Anush Dwivedi, and now I'm going to discuss about the models we built for analysis. We built 5 models, of which 3 are multiple regressions. The second one is logistic regression, and the third is cat decision tree. Before running the regression model, we manually divided our data 60% into training and 40% into validation. We did this via IBM SPSS stats, and all the results are shown in the slides are calculated on the validation. As our primary dataset had no target variable, So we build another variable where we count each and every type of crime, and we build a new variables such as crime rate for each. Our secondary bit data has a frequency of all type of crime. We also merged weather data and unemployment data in the our secondary crime data set. Now all the variables available in this secondary crime data set are the continuous variable. So multiple linear regression model is the best model for predicting continuous target variable. So we chose multiple regression model as our first model. In our regression model, we use homicide, battery, and sexual assault as our target variable because we know that homicide and sexual assault has a bad impact on human life, and battery is the crime that happens very frequently in the city. So in our first linear regression model, we took homicide as a target variable, all the weather parameters, unemployment rate, and 32 crimes as our input variable. We used backward elimination method for variable selection, and we took 90% of significance label because we had a very few number of rows. After regression, the result is in front of you, and as you can see that the weapon violation and the cloud cover appear as uh, the variable which has a positive impact on the homicide, and the liquor law violation, mean humidity, and mean wind speed has a negative impact on the homicide. It means if the weapon violation increased by 1 unit, and then the homicide will be increased by 0.030, holding other variable constant. In our second regression model, we took sexual assault as a target variable and weather, unemployment rate, and other crimes as our input variable. As our previous model, we took 90% significance level in this model, and backward elimination method for variable selection. After running the model, we found that narcotic crime has a positive impact on the on sexual assault rate. It should be because when a person is drugged, when he is not in his sense, he is more likely to do such type of crime. We also found that temperature and the wind speed has a positive impact, and the liquor law violation has a negative impact uh, on the uh, sexual assault crime rate. In our primary data set, we merged uh, police location and the business locations distance from the location of crime. So we wanted to see these distance effect with the crimes and other variables such as hardship index and the per capita income effect on the crimes. So we converted 33 primary types of crime into binary target variables such as index and non-index crimes. These are based on the IUCR codes given by Chicago Police. And following us is the output we generated via a logistic regression model uh, into IBM SPSS modeler. So as we can see in the output, which is showing the variable importance, hardship index appeared as the most important variable. Crime distance from business miles appeared as the second important variable. Per capita income third, and the person household uh, below poverty uh, showed up as a least important variable in the model. In the form of our final model, we used decision tree, which was the biggest model we used and we generated in our analysis. We used exhaustive cat tree, which is a modified version of a normal cat tree. We built this tree model because we wanted to see the pattern. We wanted to see the distribution of each type of crime with police locations, business locations, distance from crime location distance and the police location distance, and the crime location distance with the business location distance, and uh, hardship index. Just we wanted to see that what if there is a bar, is there probability of crime, is there, if there is some good location, what is the probability of crime. So we uh, in order to build this relationship, we use to generate exhaustive CAD tree. So after generating exhaustive CAD tree, we found some significant results, such as distance from particular business location to crime location site increase. It increases the number of crime. And if the hardship index is between 51 to 84, is a large probability of crime occurs in that district. Out of bad tree appear as the most happening crime in the city and in the area where the hardship index is 51 to 84. The primary type of narcotics generally happening all generally taking place out of the city are near to the business locations, where theft is more likely to occur near the business location also. The district where the hardship index is near 70 to 89, the primary type of burglary, battery, criminal damage, theft have high increasing trend. And um, and we actually generated many significant results using this tree, and I'm just telling you some of them. The likelihood of the primary type homicide is higher if public places are nearby. So if there are so many public places, so there is a primary type of homicide, a primary type of murder has more probability to be occur.
Hello everyone, my name is Ruben Cardoza and I'm going to explain the next part of our project, which is the models assessment. As you all know, our project is consisting of three main models. The first one, multiple regression. So let's assess this model now. The strengths of multiple regression include predicting crime rate of each crime per month with respect to other continuous variables such as unemployment rate, temperature, wind, etc. The R-square of the Brecht's models are around 70 to 90% and are significant at 95% significance level except for battery, which is significant at 90% significance. Now let's talk about the weaknesses. Since we had very limited data of only 60 rows for building this model, the model may change as the sample size increases. Owing to the lack of sample size, we were not able to test this model. Let's move on to logistic regression. The strengths of logistic regression are as follows. It is very handy in predicting index and non-index crimes with respect to unemployment rate, distance of the crime from police stations, distance of the crime from public places, etc. The weaknesses of this model include that it can only predict binary types of crime. It will not work if we wish to expand the dimension of crime types. It is not the best model we have made in terms of predicting power. Finally, the Chade decision tree. The strengths of this include all the 33 types of dimensions of the primary type of crime and use it for predicting, including independent variables such as unemployment rate, hardship index, distance of crime from the police stations, and distance of crime from public places. It not only helps in predicting but also classifying crimes. This fact can help us in understanding the nature of occurrence of crime and hence impart us a better understanding of the crimes. The only weakness of this model is that since it deals with so many dimensions, 33 in our case, interpreting it becomes a hard thing. Now let's move on to the choice of our final model. If we wish to study the crime rate of crime per month with respect to variables like unemployment rate, weather data, per capita income, etc., we will use the model to predict crimes. Logistic regression is used to predict the significance of index and non-index crimes with per capita income and hardship index. So if we seek to predict indexed or non-indexed crime with respect to prevailing hardship index, unemployment rate, distance of crime from police station, etc., then we would use this model. And if we wish to expand our analysis to all the 33 dimensions of crime and use independent variables such as hardship index, unemployment rate, distance of crime from police station, etc., then we would use the CAD tree to serve this purpose. Now let's talk about our original versus final vision. Initially, we planned on identifying factors influencing the crime rate and building a predictive model on those identified factors. We thought of using arrest, location of crime, type of crime for our analysis initially. However, we expanded our project by not only identifying the factors influencing crime, but also expanded the perspective of our analysis by forming 5 different models to predict the crimes. We expanded our analysis to consider all the 33 dimensions of the variable primary type of crime, thus expanding our project.